Hello everyone, it's December 26th. Alright, let's do this. Maximum bags with full capacity of something. Of rocks. You have n bags, number from 0 to n minus 1. You're given two zero-indexed arrays, capacity and rocks. The ith bag can hold a maximum of capacity rocks and currently contains I rocks. You're also given integer additional rocks. The number of additional rocks you can place in any of the bags. Return the maximum number of bags that could have full capacity after placing the additional rocks in some bags. So in this case, basically we can have a list of values with how much more we need in order to reach maximum capacity. And then the question is, how should we distribute the additional rocks into them? So the additional will be 1, 1, 0, and 1. And we have two additional. So what we asking, the maximum bag that could have full capacity. The ones are already 0, they're already gone. So 2, we can split 2 so we can get 3. The second one we have 8, 0, and 2. And then the total, yeah, we can have all of them. A rocks and rocks. There are only three bags. Okay. Yeah, so we get a list. We can get rid of all the zeros so we know. And we always want to find the ones, fill the ones with the smallest. So we just sort them and then just keep adding. Alright, we keep adding until we hit. Yeah, I don't think this one's that hard. Unless I'm very mistaken, this one seems to be not that hard. Okay, so we have capacity, so we need a difference, which is capacity minus rocks, right? And then we need to sort, so we have to, remaining to add shall equal to C minus R for CR in zip capacity. Zip this in the rocks. Oh, we can actually sort it. Right? I can sort this, and then rest is going to be 0, and then added equal to 0 as well, and then for R in rem, right? Actually, we don't need this. We can say if additional, right, rocks is larger or equal to R, then additional this minus equal R, and rest will plus equal 1. And then we keep doing this until else, then we'll break. Now we'll return rest. Okay, give it a shot. 3. This shall be 3. Oopsie doozy. Okay. Capacity, rocks, additional rocks. Okay, looks to be okay. Just go for it. This one's pretty simple. Get the difference between capacity and rocks. Sort it and fill as many bags from the as many bags as possible, right? With the smallest remaining needed. Ascending and fill as many bags as possible from left to right. That's it. Check the solution. Now we can check here. Greedy. Oh, look at this. Yeah. What is that like last time? Yeah, it's the same thing. Okay, let's try this one. Minimize the maximum of two arrays. We have two arrays, 1 and 2, which are initially empty. Add positive integers to them such that they satisfy all the following conditions. Array 1 contains unique count 1 distinct positive integers, each of which is not divisible by divisor 1. Array 2 contains unique count 2 distinct positive integers, each of which is not divisible by this. No integer is present in both these two. Given this, return the minimum possible maximum integer that can be present in either array. So in the first one, we want maximum was 1, which is not divisible by 2. And it has to be a positive integer. So it's 1. And then this one is 3, 1, 2, 3. No, 2, 3, 2, 3, 4. That's why it's a 4. So we have 2 counts in the first, 1 count in the second. So 2 counts in the front cannot be divisible by 3, so we can do 1, 2. Then this 1 should be 3, so it would be 3. A count cannot be divisible by 2, so it's 1 all the way to here. 2 counts cannot be divisible by 4. So I cannot take any of these because they are all divisible by 4. Oh, I can take 2 and 6. That's what's 15. Okay. Does it matter which one we go first? If we want to do this first, so I'll do 2, not divided by 4, I will do 1, I'll be 1, 2, right? We would have done 1, 2 on this side. And then in here, I cannot take 1, so I have to take 3. So I have to take another one, will be 17. It does matter. It does matter. Which means we shall take as many as we can, but we shall satisfy the longer one first, because if we satisfy the smaller one, then the longer ones might suffer. So we satisfy the longer one first. Well, in this case, if we satisfy the longer one, will be 1, 2, 3. All right, it will be 1, 2, 3, and then 1, 2, 3 are taken, so it'll be 4. Yeah, it will be the same. If we satisfy this first, yeah, we did satisfy this first. Does that make sense? Or maybe we can, because we want it as small as possible, right? Yeah, the reason we satisfy the longest, because when we satisfy the longest, it might run out longer. So when we satisfy the other one, we might have more options. Or we might be able to take the thing that's in between, right? Otherwise, we might not. And there's also another consideration. If the divisor is bigger, yeah, actually, I don't think the divisor really matter that much. You can try. You can try. You say, I want the unique count to be bigger, to be considered first. Yeah. So whatever it is, we can do, right? We have 8, and then we say neither of them can be a divisible by 2, or when neither can be divisible by this, then we can simply count how many we want. Yeah, we have a divisor 1, right? Basically, yeah, we just consider unique count 1 has a more. So we say everything but before, from 1 to d1 minus 1, right? And then d1 plus 1 to 2d1 minus 1. How many is this? So each one have d1 minus 1 number of things in it. And then we can compute, right? Whatever it is. And then we have d2, right? And we have d2. Then we have the same thing, but it cannot overlap with d1. So what do we say? Yeah, because the biggest is determined by the one with a larger count, right? That's the one with a larger count that decides on how much. We have count of this, and we have 5. So we have 5. So everything. So well, we can do this as like the largest we can reach. The largest we can reach. Maybe that's what we need to do. The largest we can reach. We have a divisor. We have a number of count. So we can take the largest that we can reach. And then depending on what is the largest we can reach, we do it there first. Right? Yeah, so it will not be... Nah, that's not right. I don't have a good method. Yeah, I can get all of those, right? And then we switch it to the other one. And then however much this one we cannot hit, right? Yeah, I think I just need to prove that this is the best way. This greedy method is the best way. So I was trying to think, how do I prove? To prove what I need is to show that this is absolutely the best way to go, to fill the one with the longest first. So I can say if I don't do it, I don't fill this one, but I know if I fill the other one, I said if I don't fill it first, then we'll have something left. Then will definitely be longer, or at least is it the same, right? And then we'll fill the smaller one going first. Yeah, I think the argument is that we fill the longest one, we all have gaps, and the gaps may help us to fill the other one. That's the only thing we can ask for. Okay, I guess I'll just go with this and see how it works. So what would you do given the divisor and given the number of counts? You will find the largest one. Okay. Then what? Then you need to find a second divisor, right? If you find a second divisor, but not all the values can be taken. So we know which values are taken, right? We know which values are taken. Oh, well, not which values are not taken. We know which values are, when we set a 1, we know which values are not taken. So the value is not taken, that's before, right? Before getting even bigger values of one that's not taken. So we just need to know if they are divisible by that, right? I mean, if they are all smaller than the value of the second divisor, then we're all good, right? We're all good. And if they're bigger, if I starting from some point that they're bigger, then we need to see we need to get all the values. And then if the two values are co-prime, then everything that's in the first one can be in the second one, right? If they're co-prime. And then the problem is just starting from this towards the end. And that will be a, similar computation. I won't worry too much. Okay? If they're not co-prime, so they have a GCD, right? And we can find this GCD. And then find the GCD and find, because we know this, and then it cannot be multiplied by that. Yeah, because it will be the GCD multiplied something will be the first factor. The GCD multiplied a different thing of the second factor. And then the ones that we can fill is just 1 times the first factor, 2 times the first factor, all the way to, k times the first factor. And we just want to, among these, right, which one is a multiple of the other thing? If it is, then those cannot be used. But if it is not, then they can all be used. Okay, this is going to be a little bit hairy to code, but I'm going to give it a shot. Ooh, hairy. This is indeed hairy. Very hairy stuff. So, what we can say is, if unique count 1 is larger than unique count 2, then, no, smaller. So I want to swap them. And unique count 1, unique count 2 equals unique count 2, unique count 1. And then divisor 1, divisor 2 equals divisor 2 and divisor 1. So we want the first one to be longer. And then what we can do is define how many do we need. Okay, so what we'll do is, get the one that's excluded, because we go one blah blah blah, we want to find the one that's excluded in a first count, right? Who are excluded? We'll get a list, okay, of k. Those are excluded. Okay, so we can say k equals 1. What's the first? K equals 0. Okay, and then actually k equals 1, and then we say while count. Okay, hold on. What are we looking for? We're looking for divisor 1 multiplied by k, right? And then minus 1. That's the total number we have. Okay, and we just say while divisor 1. We'll just divide then, right? We'll just divide. Hold on, we have Hold on. We have a divisor, right? We have a divisor 1, and then each time for each count, we can do divisor 1 minus 1 number. So right, so this multiplied by k. Okay, how many we do take? We need to do a div mod of this and count. Right, which means just count unique 1 divided by d1 minus 1. Wait, hold on. No. Is count divided by this equals k, right? So we say k shall equal to unique count 1 divided by divisor 1 minus 1. Okay, that's how many divisor 1 we are not taking. Okay, and then we'll have a remainder. So basically we have a remainder here. So we actually do a div mod of these two. All right, div mod these two values. So what I get is we need that many, and we have these remaining. Okay, so we can compute the starting point for the next. And we need to have this much more, which is just the divisor. So for the next start, shall equal to k multiplied by divisor 1, right? So take this much, this much. All right, because we have 1, 2, 3, 4, and the remaining is this. So just k times divisor is that value, and then plus r, right? Plus r. Shouldn't be plus r plus 1. Yeah, I think should be a divisor 2, right? So each time I only get 1, and I got an 8. It's 16, because this is not Oh, because r is 0, so the next one is 16. The next is start. Hold on. So we need to have 3. All right. 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 3. 2 with remainder 2. So that should be 2, 3, 4, 6, 7, 8, 10. So it should be 4 times 2 plus 2. Pointing at this. So yeah, I think I do have to add 1. It's the next start. But it doesn't fit here. Because for this would be 8. This is 1, so we would get 8. K is 8. 2 times 8 is 16. And 16 plus 0 is 16. I will be starting with 17. That's not what we want. All right? Huh. Hold on. Yeah. Yeah, so we take this, so we have this, right? So I have 2, and then it's 8. 8 plus 2 is 10, so these are all included. Huh? Don't tell me that it's different. So that's 6. Divided by 3 equals 2. 0. Oh my god, it is different. This is the starting point. So it depends on whether r is equal to 0 or not. If r is equal to 0, then we're hitting dead on. If r is not equal to 0, then we have to add this and we have to add 1. So depending on whether r is equal to 0. So we say I is equal to 0, is not equal to 0. If it's, we're going to do an int of this. If r is equal to 0, which means r not equal to 0 is false, then we don't add. But if r is not equal to 0, shoot, I need to add r. I need to add r no matter what. Because if r is equal to 0, we don't want to add anything. But if r is not equal to 0, that means we have remainder. Then we need to do a little bit. Okay, so this is the next start. But it doesn't matter. So we get the first one, we have the k, right? And then I need to check divisor 2. Okay, when you check divisor 2, because I have r, which is basically just 1 times d1, 2 times d1, 3 times d1, all the way to k times d1. And then the next star we have whatever the next star we have. So now what we want to do is to look through 1 times d1, 2 times d1, all the way to k times d1, and just to see if it works, right? If it works. Not if it works. See, any one of these can be divided by divisor 2. And how do we do that? We get GCD of d1 and d2, right? And then that will be a value. And then if this value is larger than k, well, we can count how many from 1 to k is also in this, so we can get an estimate. So we need a G, we can say math.gcd, divisor 1 and divisor 2. Okay. And then we can do, because it's 1 to k, so we can do k divided by g to let me know how many are in there. So k divided by g. Okay, so this will be the so this is handle, we handle, so this is handles unique count 1, right? And then we need to handle unique count 2. Okay, and then to do, we're gonna call remaining 2, remain 2 shall be unique count 2 minus what? So we have k, then we need to know how many of them cannot be made. So just divided by this. So I can actually do this, which is totally fine. All right. So by doing this, we get how many is remaining. Because if this is bigger, then there will be 0, then all the k can be used. Or if this gives me, wait, hold a second. Shouldn't be, because the GCD will return, like if it's 1, like if these two are co-prime, hold on, that doesn't sound right. So we have a GCD, right? Okay, we have a GCD, which means it should be D2 divided by, because this one will be 1 times this GCD times something, 2 times this GCD times something, right, all the way down. And then D2 will be this GCD times another thing, right? So in order for these two, this to be not divisible by this, what we want is, because they all have the GCD, right? So the GCD times this 1 something, 2 something, and this something, and these two are co-prime, right? So what I want is for, because this and this are co-prime, right? So for the only way for this to be, for k times g times, question mark, for this to be divisible by g times this, is for k times this divisible by this. Okay, so k times this divisible by this, which means, and then also these two are co-prime. So the only chance is for k to be a multiple of this, of the triangle. K to be a multiple of this, which means what we need to do is, we have the GCD, right? So this is k divided by GCD of these two, and we need to have another one here to be divisor 2 divided by this. So divisor 2 divided by, okay, I need to do it another way. So we'll call this, so co-prime 2, right? Co-prime 2 shall equal to divisor 2 divided by math.gcd this. Okay, then this will just be divided by co-prime 2. I know how many times we have this co-prime 2. And now, if the co-prime 2 is huge, then it'll be 0, then all the k can be used. If the covariant 2 is small, then we might have some, so we'll remove those, right? But then we have the remaining count. And then we just need to, from the next start, okay, from the next start, to see how many more do we need. How do we compute that? Well, we compute that by starting from this, right? We need to find however many that we can find with just from start, from next start, from this value, right? And then we need to count remaining 2, right? So what we can do is we can do the next start divided by divisor 2. Okay, next start divided by divisor 2 will give us what will it give us? Or will give us where it will be. The next start divided by divisor 2. It multiply by divisor 2. Okay, so divided by multiply will give us where that value will be. Okay, and then we can get the next value. Unless, there's no unless. So if the next value is divisible, then we're doomed. If it's not divisible, now it doesn't matter. We just want to find the next one. Just the one that's divisible by divisor 2 that is larger than next start. Okay, so we find that, and then we can count the numbers in between, and then remove that, and then we can do the same thing. Okay, so next start, we can say the next d2 divisible next multiple of d2 shall equal to next start divided by divisor 2, right? And now plus 1, and the whole thing multiplied by divisor 2. Okay, then rem2 will, hold on. So we can say if rem2 is smaller or equal to 0, so which means we already get rid of all of them, then we can return already. We can return the biggest is maybe I should put this one here. This is the next start. Should be the next start minus 1. That's the biggest in it. Else, that means we still have remaining left. Then we find the next divisible, right? And then we can count the number. This is next multiplied by d2. So it'll be this one minus 1. Okay. So this one, 2 shall be minus equal to this minus 1 minus next start actually just this. Okay, again, if rem2 is smaller or equal to 0, then we'll return. What do we return? We return next start plus rem2 minus 1. Hold on, this doesn't make any sense. This is the next start. This is the multiply. And then what we want to find is from this value to this value, how many there are. So it's this minus 1 minus this plus 1. So yeah, so it's this minus this is a total. And then we have something remaining. And then if this minus this is smaller or equal to 0, that means we can go from here. So the remaining. So we need to find a 1 minus this plus 1. Yeah, this is right. Okay. Else. So after we add this, then we can say we just want to find from this, right? What if it's 1? Divisor is 1. Divisor will not be 1. Okay. So which means now we just from here, we just want to find. Okay, so we have the remaining, and we have the remaining, so we can do the same thing as, you know, we can do kr equal to div mod remaining 2 and divisor 2 minus 1, right? So we can do that to know how many we need. And then we can have boom, 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 and then we have some remaining. Then the end, right, what is the end? The end shall be k times divisor 2, all right, which is basically how many we have this, okay? Plus next multiple d2 plus this right, plus this. So that will get us to here. Okay, then we need to plus r minus int r is equal to 0. So if r is 0, right, so we need to get one back. If else end is equal to, then we will return this end. In fact, we can actually do this in both ways to decide which one we want to take first. All right, we can actually do this as def solve. We can call it d1, d2, c1, c2. Then we don't need this. Okay, so this one we'll call it C1. This one called D1. Call it D2. And this one we'll call it C2. Okay, then we will say we'll return minimum of the maximum. So return the minimum of solve divisor 1, divisor 2, unique 1, unique 2. Oh. And then we swap the 2. Not 100% sure. This basically is just greedy. We're not mingling the both. Okay, give it a shot. 4. 3, 15. Damn, that was terrible. Oh my god. Okay, let's see. Just need to debug this thing. I think D1, D2, 2713. And I'm doing D1, D2 first. Okay, let's do this. D1, D2, C1, and C2. Okay, we're gonna do print KR and the next start. Coprime 2 and 7. Coprime is 1, so we can print remaining 2. Okay, and then we need next mult 2, and then rem 2. Then we need KR end, indicating we're ending. Okay. So we do 2713. We get, because it's 1. Okay, we have 2. So D1 is 2, D2 is 7, C1 is 1, C2 is 3. So it's 1. So K is 1, R is 0. Because we use C1 divided by 1. Right? So basically, we say we'll get 1 of them. So the next start is 2. That is correct. So we take 1. My 1 is gone, so next start was 2. And then coprime should be 1. And rem 2, coprime 1 and K is 1. So we have 3. 3 minus 1. Because it's 1. Oh, hold on. That is not right. Coprime is 1, right? Then we have K, we have 1, so we have 1, 2. Yes, because this coprime is 1. And D2 is 3. No, D2 is 7. 7 divided by 1 is 7. Okay, so this is 7. And then k is 1, so that's a 0. So c2 minus 1, that's why remaining is 2. Which means we have 3 remaining, but we only need to go with 2. Because I can take whatever. Yes, I can take this. Take the 2. So the next multiple is 7. That's correct. And the remaining is minus 3. Yes. So the next start is 2. Okay. So from 2 we need to add, right, next start is 2. So from 2 we need to add, oh, I see. That is not right, because I already changed the value. Ah, damn. Okay, so I should say if this minus this, right, if this minus this is smaller than 0, then we do this. Else we do this. Okay, we get a little bit better. It's a little bit better. Okay, and you also need to signal the start. As a start, let's do this. Alright, so the next start is 2 plus remain is 2. 2 plus 2 is 4. Huh. I shouldn't minus 1. Really? The next start. Okay. And then we go 2 more. So the next start count. Next start shall count. Next start shall count. But what if the next start is divisible by d2? Damn, that is a concern. Yeah, we need to redo the next start. So if next start is divisible by d2, the next start plus equal 1. Wait, hold on. Do we plus equal 1 or we not? So next start is plus this. Okay? So we have to add 1. And if this doesn't work, we have to add 1. Or if it's divisible, we'll be here. And the next start in here. Yeah, we always have to add 1. Then the next start is correct. Then we do this. Then has to be the end minus this. Alright, so the next start now is next start. Next start is 2. then we have the remaining 2 is not right. How do I get the remaining 2? We got a coprime, right? So we have those. This means one of them is already taken from the previous. Yes, because but that's not taken because the previous only 1. Yeah, k is equal to k is equal to 1, right? K is equal to 1, which means k is equal to 1. So k is the last one, right? K is here. K is this one. Okay. Then we're trying to see this all the way to k. How many of them? And now we find out we have 1 of them. Okay. Okay. Then the next start. So these 2 overlap. I see. The next starts and the k overlaps. Now we should do k minus 1. Because this is not part of the previous. We want to know how many of the part of the previous, which means it has to be k minus 1. Yeah, it has to be k minus 1. Those are the number that we can take that's already been included. Not included, that has been handled, because the next will include k, right? Next we include k. So that's why we do k minus 1. Then this one is right. Now we pass all 3. Now let me delete all this. This is the next start for D2. This is the number of values not taken in unique, not taken in C1. Yeah. Not taken from 1 to next start minus 1 that can be taken in C2, in D2. Remove the number of values not taken in but can be taken in D2 from the total count from C2, right? From C2. So this is to make sure that we take full advantage of all the values from 1 to next start minus 1. If after taking full advantage we already fulfill the requirement of C2, then the end of the largest, right? And the largest value of under D1 is the answer. Otherwise, we first find the number of values to take from next start to the immediate next multiple of D2. Right, we say if there is enough values in this gap, we're done. Yeah, we have found the largest value under D2. Otherwise, if that doesn't work, right? Otherwise, we redo same thing as D1, right? We do the same thing as D1. Okay, so these are correct, but I do not have a lot of hope for this. Yeah, let's just submit it. I don't want to. If it's not right, then we handle it. It's not right, then we handle it. Okay. Disappointed? Yes, of course. Output 21. Answer shall be 20. But it's fine. Okay. Maybe I should keep those. Okay, and then what do we want? We want to print KR is just not really that important, but that's fine. Next to start. Okay. And then for this, we want to print let's do coprime remainder 2. That's it. This what do we want? Next, 2. And for this, of course, same thing. KR and and 21, and 20. Both come up with n is 21. That is bonkers. All right. So what we have is D1, 16. C1 is 14. D2 is 12. C2 is 8. Okay, let's just by hand. I say, doesn't matter if I do D1, C1 first. I have 16. D1 is 16 and then C1 is 14, so I can do 1 to 14. Right? So the next starter will be 15. And D2 is 12. Okay. So from 15 towards 24. And I want 8. That's 9. Hey, what? Oh, D1, D2, my bad. D1 is 16. D2 is 14. C1 is 12. And C2 is 8. My bad. Okay, we'll redo it. So 1 to 12. Okay, so we start with 13. And then we need 8. Right, we have 13. 14 needs to be skipped. And then next one is 28. And I need how many? I need 14. No, I need 8. So we can do 12, 13, plus 7 is 20, right? 14, 15, 16, all the way to 20. 7 and 8. Yes, it's 20. How come you came up with 21? All right, next start is 13. That is correct. Co-prime is not co-prime is 7. Yeah, but just 2. So we need to find. Oh, I see. I see the problem. I haven't even. Oh, but K is 0 though, right? K is 0. Damn. I have a. K is 0 and I have a -1 issue happen. So K has to be larger. Right? K has to be larger than 0. I mean, if K is 1, we can try. Right? Doesn't matter. Minus K is 1. Oh, this is just add 1. So among the 0. Wait, what's -1 divided by this? Oh yeah, that's not gonna work. Say if K is larger than 0, I also see 2. Ooh, that ain't right. But rhyme 2 is 8. That is correct. Yeah, I did have the. Okay, rhyme 2 is 8. That's correct. Next multiple is 14. That is correct. So next is 14. K is 0. R is 7. Because 8 divided by D2. What's D2? D2 is 14 is 13. Right? Hold on, I need more things. Round 2 is 7, that's correct. Because we take 13, so it's only 7. Okay, it's only 7. So we did the 7 divided, so your remainder is 7, yes. Now the end is K is 0. So that's 0. Next, this is start. Next, multiple C2 is going to be 14, right? So 14. Then we'll plus R, plus 7 is 21. Hold on, so we have this, and now we do hold on, 14, we cannot count 14, right? So it'll be from 15. So 1, 2, 3, 4, 5, 6, 7. But I need 8. Hold on, it is 21 for the first situation. Oh, I see. No, you don't see. Oh, yes, I see. Now, this is right. This algorithm is right, but it's not as wrong for the problem because I can take 14 in the first. So I can do 1 to 11, take 14 for D1, and then I take 12, 13, and because 14 is not wasted. Damn. And that can go all the way to 20. Yep, in either algorithm we'll have waste. Holy crap. We'll have waste. So we want to reduce the waste. And what do you mean by reducing the waste? Well, I mean is just if something cannot fit for one, we try to leave that for the other. Right? Okay, I have another thought. So we have D1 and D2, right? So we just keep going until D1. We're gonna say everything belongs to D1 until D1. This one will count for D2. Right, so D1 is small, D2 is big. So we go all the way to D1, and then D1 will count to D2. And then we keep count. But what if we hit D2? And what if D1 and D2 are or we can do we do, D1, okay? We handle D1, and then, so we follow what we do, okay? We follow what we do. But then, we swap. Every time we hit D2, then we swap with something in the D1. Okay, I like the swapping idea. Which means, because up until here, we don't have waste, right? We don't have waste, unless there's something is both, yeah. So we don't have waste here. We don't have waste here. We have waste here. That's where we have the waste, right? So whenever we hit, so we have K, right? We have K of them for the D2. And for each one of them, I can try to say, can I swap with something from the front? Then how do I know I can swap with the front? Well, I have so many in the front, right? As long as this thing is not divisible by D1, then we can swap. Which means, and also we need to know how many is in the first. I know how many is in the first, right? I know. So basically, we just say, ooh, hold on. It's the same thing. It's the same thing as this. It's the same thing as this. It's exactly the same thing. We have the coprime 2, right? So these are just K times this. So we just need to say divided by coprime 1, right? To know how many we can potentially swap. So which means this is the remaining. Okay, so we get this. And then we say coprime 1 equals D1 divided by, my answer, I just call it G equals minus GCD, D1, D2, so I don't have it computed twice. Alright, so divided by G. So we need to find how many potentially we can take, right? So potential swap shall equal to, again, K minus 1, right? K minus 1, because this is the last one that's not in the potential to take. Yeah, so K minus 1 minus K minus 1 divided by coprime 1. So this will be potentially among these, how many we can swap, right? How many we can swap. And technically we can swap all of them, right? And also depending on the K, so if K is equal to larger than 0, if K is 0, then potential, so it would be like this, if K is larger than 0, right? If K is equal to 0, K will not be equal to 0, because if K is 0, that means we should have already handled it here. All right, so K is not 0. K will definitely be larger than 1. And then I will know the potential number of swaps, right? K is 1. K is 0 in this case. That's not good. That's not good. Because the next multiple 2 right? So we start from the next multiple 2 and all the way to whatever. Right, we start from the next multiple 2 and then we say the remaining has this much. Okay? Hold on. That's not how we want. Yeah, we should see if we can swap. But if the one that we swap with is also divisible, what are we going to do? The one we swap with. Yeah, it's likely it might be divisible by this. Gordy, this is not right. Oh, I want to swap. That's not a way to go. You know what? I feel I'm on the wrong track. I don't feel like this is the right way to go. I'll leave it here. Man, this one's a bit tough. It's a little bit tough. Think about it again. Alright, I'll see you guys tomorrow. Adios.